Good day. I am Colleen B. Docog, one of the reporters of Group 5. So in this lesson, we are going to tackle about integrating factor, specifically non-exact differential equation. So it is said that if partial derivative of m with respect to y is not equal to partial derivative of n with respect to x, then the equation is not exact. Now, the role of integrating factor is it is a factor in which when multiplied to whole non-exact differential equation, the non-exact will become exact. Since it is not exact, we are in need to find its exactness. And this equation will help us find its integrating factor that will make the equation exact. For letter A, partial derivative of m with respect to y minus partial derivative of n with respect to x equals function of x, then its integrating factor is e raised to integral fx dx, and it is used to x alone. For letter B, partial derivative of m with respect to y minus partial derivative of n with respect to x equals function of y, and its integrating factor is e negative integral of fy dy, and it is used for y alone. In order to know which of the two is the right one, you need to see if it can express the function of x or function of y into a constant or into a single variable. Then if any of the two can, then that is what we are going to use. Additional information for function of x, the result should only be constant, a variable, or constant plus variable but not two variable at the same time. For function of y, it should be constant, variable, or constant plus variable but it is y but never x and y. Now, to further understand the lesson, here's an example. Example number 1, solve for the differential equation of y squared dx plus quantity 3x squared plus y squared minus 1 dy equals 0. So, the first step is to find its m and n. So, for this equation, our m is y squared and our n is 3xy plus y squared minus 1. To find its exactness, our formula is partial derivative of m with respect to y equals partial derivative of n with respect to x. So, the first solve is for the m. So, partial derivative of m with respect to y. So, in order for us to find the m, we need to derive our m in this equation. Our m in this equation is y squared. So,
to y. So, now we have our n. So, for the partial derivative of n with respect to x, so, the same process. We need to derive the n. So, our n in this equation is 3x squared plus y squared minus 1. So, if we derive this, we will come up as an answer of 3y. So, now we have our m and n. So, our m is 2y and our n is 3y. Clearly, they are not equal. So, it is not exact.
So, after solving, we clearly see that they are not exact. Now, we are going to solve for its integrating factor that will make the equation equal and exact. So, we can choose between the formula for function of x and for function of y. Now, we will use the formula for function of y. It is said that the formula for function of y is partial derivative of m with respect to y minus partial derivative of n with respect to x over m. So, lagay muna natin yung na-solve natin for m and n. So, for our m, we have 2y, and for our n, we have 3y. So, ilagay na din natin yung original equation for the basis para sa m. So, our original equation is y squared dx plus quantity 3xy plus y squared minus 1 dy equals 0. So, diba meron na tayong value for m and n. So, we are just going to substitute. So, our m is 2y. So, minus n is 3y over. So, ang m natin para sa equation na to is y squared. So, y squared. Then, simplify. Negative y over y squared. So, negative 1 over y. So, ito yon. So, para makuha natin yung integrating factor, ang formula for function of y sa integrating factor ay e negative integral of fy dy. So, isa-substitute lang natin to dito. So, e raised to integral of, so, ito yung function of y, negative 1 over y dy. So, simplify e, this will become ln dy, and further simplify, ln is also equals to 1, so e, then 1, this will become y. So, our integrating factor is y.
Solving, we come up as y as our integrating factor. The next step is to multiply our integrating factor to the whole original equation.
Multiplying our solved integrating factor to the whole and original equation. Our equation earlier is y squared dx plus quantity 3xy plus y squared minus 1 dy equals 0. So, ang na-solve natin na integrating factor is y. So, we are going to multiply it y. So, distribute will become y cube dx plus quantity 3x y squared plus y cube minus y dy. So, balik tayo sa first step. Diba ang first step na ginawa natin is to find the m and n. So, ganun din yung gagawin natin dito. So, for this equation, our m is y cube and our n is 3x y squared plus y cube minus y. So, ganun din. So, yung second step is to find for the partial derivative of m with respect to y. So, our m in this equation, we are going to derive. So, if we derive y cube, we are going to get 3y squared. So, next is solving for the partial derivative of n with respect to x. Same process. We are going to derive our n. Our n is 3xy squared plus y cubed minus y. So, if we are going to derive this, since we are getting with respect to x, if we derive this, we will come up 3y squared as an answer. So for our m, we have 3y squared, and for our n, we have 3y squared. So, as we can see, we have now an exact equation. They are now equal. So, getting y or solving y as our integrating factor makes it correct that it result to having an exact equation. So, our if y is correct. So, we have now our value for m is equals to 3y squared, and our value for n is also equals to 3y squared. We can see that they are now equal. So, therefore, our integrating factor y is correct, that it results to having our equation exact. And since we have solved for its exactness, this is not the last step. Our last step is to solve for our exact DE. And in order for us to do that, we have partial derivative of f with respect to, unahin muna natin with respect to x. Respect to x equals m quantity of x and y, or simply x and y. So, cross multiply, we have partial derivative of f equals, our m is y cubed, and then dx. Now, we are going to integrate both sides. So, f equals, since we are solving with respect to x, any variable rather than x is considered constant. So, we can factor this out. Pwede natin siyang ilabas. Y cubed integral of dx. So, f equals y cubed. So, the derivative of x is x plus p of y. So, p of y is also considered as plus c. Since we are solving with respect to x nga, diba ang sabi, any variable that rather than x is considered constant. So, if we derive constant, diba 0 or plus c. So, it can also be plus c. Now, we are going to solve an exact DE with respect to y. In order for us to do that, we have partial derivative of f with respect to y equals n quantity of x and y. So, cross multiply, we have partial derivative of f equals, so our n is this, 3x y squared plus y cubed minus y dy. So, the next step is we have to integrate both sides. We have f, then we need to distribute the dy. We have integral of 3x y squared dy plus integral of y cubed dy minus integral of y dy. So, since we are solving with respect to y, diba ang sabi, any variable except y is considered constant. So, dito, pwede nating ilabas yung constant. So, dito sa first, ang pwede nating ilabas is yung 3x. So, copy y squared dy plus, ito, copy lang to, y cubed dy minus integral of y dy. Now, we are going to simplify this. Copy 3x. The integral of y squared dy. So, power rule to. Y raised to n plus 1 over n plus 1. So, this will become y cubed over 3 plus, ito naman, magiging power rule ulit. Y cubed will become y raised to 4 over 4, and here also, y will become y squared over 2. Now, we can further simplify this. We can cancel 3 since they are the same. Cancel. Then, dito wala naman tayong pwedeng i-cancel at saka dito. So, sulat na natin yung natira. X, y cube, plus y raised to 4 over 4 minus y squared over 2 plus p of 1. We're now down to our last process. In order for us to arrive at our general solution or our final answer, we need to evaluate our f. Since they are both f, we can evaluate them. So, it will become like this. Y cube x plus p of y equals xy cube plus y raised to 4 over 4 minus y squared over 2 plus p prime of y. So, we can simplify this. Since y cube x and yx cube and xy cube is similar, we can cancel out. So, ang natira na lang sa atin for p of y is this. Y raised to 4 over 4 minus y squared over 2. So, para maka-arrive tayo sa ating general solution, yung p of y, di ba ang may p of y is etong f na with respect to x. So, we can substitute our p of y, the value of our p of y to this equation. So, for general solution or final answer, we have y raised to 3 x plus yung p of y natin is y raised to 4 over 4 minus y raised to 2 over 2 or equal c, since kapag mag-arrive na tayo sa final answer, kailangan na nating palitan itong p of y into c, since diba gano'n naman yung rule sa integral. Or pwede natin silang i-cross multiply. It will become, since cross multiply, this is over 1, 4xy cube plus y raised to 4. So, ito din, pwede natin itong i-cross multiply. So, magkakaroon siya dito ng divisible 1 over 1. So, plus, minus, since minus yung sign niya dito, minus 2y raised to 2 equals c. So, ito na yung ating general solution. Or, we can cross multiply them. It will become 4xy cube plus y raised to 4 minus, since minus to, magkakaroon siya ng 1 over 1 here. So, 2y raised to 2 equals c. So, this is now our general solution for our exact DE.
I'm Gahita Alexandria Bay, and I'll be continuing Colindo Akog's discussion, wherein included doon ay yung number 2 natin, wherein ito yung given. And this is the formula that we are going to use in order to get the integrating factor. Also, number 3, wherein ito yung given, at ito yung gagamitin nating formula in order to get the integrating factor. So, let's proceed. Proceed tayo sa second equation. Sa second equation, meron tayo x dx plus dy is equals to 2xy dx. After transposing and integrating, we have x is to 1 minus 2y dx plus dy is equals to 0. Now we can have the m, which is the x, is to 1 minus 2y, and the n, which is 1. So proceeding sa partial derivatives, we have partial derivatives of m with respect to y is equals to x negative 2. So partial derivatives of n with respect of to x is equals to 0. Since we have the function of x, pwede natin gamitin tong formula na to. Wherein, magiging negative 2x minus 0 over 1 is equals to negative 2x. After na natin makuha yung function of x, we can now have the integrating factor, wherein ito yung e raised to integral of negative 2x dx is equals to e raised to negative x squared. So, ito na yung mdx plus ndy is equals to 0 natin. Wherein ito yung x is to 1 minus 2y dx plus dy is equals to 0. And e raised to negative x squared. Solve lang natin. X squared minus 2xe raised to negative x squared y dx plus e raised to negative x squared dy is equals to 0. After solving, meron na tayong bagong m, which is yung x e raised to negative x squared minus 2x e raised to x squared y, and our new n na e raised to negative x squared, which is ito. Therefore, our partial of m with respect to y is equals to negative 2x e raised to x squared. And our partial of n with respect to x is equals to negative 2 e raised to x squared. Therefore, it is exact. We can proceed now to partial. So, nakuha na natin yung exactness. Hindi na natin gamitin yung next, which is the e raised to integral of f of x dx. Wherein, in-apply na natin dito yung nakuha natin kanina. So, ito yung integral of e raised to negative x squared dy plus q x integrate f is equals to e raised to negative x squared y plus q x. Partial of f with respect to x is equals to negative 2 x raised to negative x squared y plus q prime x is equals to m. After getting our partial fraction with respect to x, we now have negative 2x e raised to negative x squared y plus q prime x is equals to xe raised to negative x squared minus 2xe raised to negative x squared y minus lang q prime x is equals to x raised to negative x squared integrate is equals to negative 1/2 e raised to minus x squared. Therefore, we have e raised to negative x squared, y is minus 1/2 e raised to x squared equals c, or 2e raised to x squared y minus e raised to x squared is equals to... Proceed naman tayo sa third equation, wherein meron tayong 2y dx plus x minus x cubed y cubed dy is equals to 0. We can now have the m wherein ito, and our n. Therefore, m is equals to 2y, dar n is equals to x minus x cubed and y cubed. After getting our m and n, we can now have our partial derivatives of m with respect to y, which is 2, and partial derivatives of n with respect to x, which is 1 minus 3x squared y cubed. After getting our m and n, apply lang natin yung formula na to. So, we have 2yn over y minus x cubed y cubed m over x is equals to 1 minus 3x squared y cubed minus 2. Comparing the constant terms, we have 2n minus m is equals to negative 1. Comparing our coefficients of x squared and y cubed, we have m is equals to negative 3. Therefore, our n is negative 2. After that, pwede na tayo mag-proceed sa integrating factor. Since kung i-compare nga siya dun sa previous problems, gagamitin natin dito is x raised to m and y raised to n. Therefore, our integrating factor is x raised to negative 3, y negative 2, or 1 over x cubed and y squared. After getting the integrating factor, which is x raised to negative 3 and y raised to negative 2, or 1 over x cubed and y squared, we can proceed to m dx plus n dy is equals to 0. Apply lang natin, which is yung 2y dx plus x minus x cubed y cubed dy is equals to 0. 1 over x cubed y squared 2 dx over x cubed y plus 1 squared minus y over c. We can now have our new m. Our m which is 2 over x cubed y, and Rn un 1 over x squared y squared minus y. Since nakuha na natin yung bago nating m and n, proceed tayo sa partial of m with respect to y and partial of n with respect to x. So, after solving, ang partial of m with respect to y natin is negative 2 over x cubed y squared, and our partial of n with respect to x is equals to negative 2 over x cubed y squared. Katulad lang sa previous example natin, integrate lang natin. Therefore, f is equals to negative 1 over x squared y plus p dy. Then, pwede na tayo mag-proceed sa partial of f with respect to y, where our partial of f with respect to y is negative 1 over x squared negative 1 y squared plus p prime y is equals to n. Y. Therefore, our p prime y is negative y p y is negative y squared. Solution to our given differential equation is negative 1 over x squared y minus y squared over 2 equals c, or 2x raised to negative 2 y raised to negative 1 plus y squared equals c.